Hello, this is going to be the standards for mathematical practices. First, there's make sense of problems and persevere in solving them. 2. Reason abstractly and quantitatively. 3. Construct viable arguments and critique the reasoning of others. 4. Model with mathematics. 5. Use appropriate tools strategically. 6. Attend to precision. 7. Look for and make use of structure. 8. Look for and expressed regularity in repeated reasoning. This is by the New York government one. So, standards for mathematical practices. The standards for mathematical practices describes variabilities in experts that mathematical educators of all levels should seek to develop in their students. These practices rest on important processes and proficiencies with long-standing importance in mathematical education. The first of these are the NCTM, National Council of Math Teachers, processes, standards for problem solving, reasoning, and proofs, communication, representation, and connections. The second are the standards of mathematical prosody, specifically in the National Research Council's report, adding it up. Adaptation, reasoning, strategy, competition, and conceptual understanding, comprehension, and mathematical concepts, operations, and relationships. Procedural fluencies, skills in carrying out procedures flexibly, accurately, effectively, and appropriately. And predispositions, habitual inclinations to see mathematicals as sensible, useful, and worthwhile, coupled with a belief in diligency in one's own efficacy. Make sense of problems and persevere in solving them. Mathematical perceptions students start by explaining to themselves the meaning of a problem and looking for entry points to its solution. They analyze givens, constraints, relationships, and goals. They make conjectures about the form and meaning of the solution and plan a solution pathway rather than simply jumping into a solution attempt. They consider acknowledges problems and try special cases and simpler forms of the original problem in order to gain insight into its solutions. They monitor and evaluate the process and change course if necessary. Older students might depend on the concept of the problem, transfer algebraic expressions, or change the viewing window on their graphical calculator to get the information they need. Mathematical proficient students can explain corresponding between equations, variable descriptions, tables and graphs, or drawing diagrams of important features and relationships, graph data, and search for regularity or trends. Younger students might rely on using concrete objects or pictures to help conceptualize and solve a problem. Mathematical proficient students check their answers to problems using a different method, and they continually ask themselves, does this make sense? They can understand the approach of others to solving complex problems and identify correspondence between different approaches. This was the first standards of mathematical practice, make sense of problems and persevere in solving them. The standard mathematical practice 2, reason abstractly and quantitatively. Mathematical proficient students make sense of quantities and their relationships in problem situations. They bring two complementary abilities to bear on problems involving quantitative relationships: the ability to deconceptualize, to abstract a given situation, represent it symbolically, and manipulate the representing symbols as if they have a life of their own, without necessarily attending to their references, and the ability to contextualize, to pause as needed during the manipulation process in order to probe into the reference for the symbols involved. Quantitatively reasoning entails habits of creating a coherent representation of a problem at hand. Consider the 5 units involved: attending the meaning of quantities, not just how to compute them, and knowing and flexibly using different properties of operations and objects. Construct. Oh, at the end, that was the end of reason abstractly and quantitatively. We're moving on to the third standard of mathematical practices: construct viable arguments and critique the reasoning of others. Mathematical proficient students understand and state assumptions, definitions, and previously established results in constructive arguments. They make conjectures and build a logical progression of statements to explore the truth of their conjectures. They are able to analyze situations by breaking them into cases and can recognize and use counterexamples. They justify their conclusions, communicate them to others, and respond to the arguments of others. They reason inductively about data, making plausible arguments that can take into account the context from which the data arose. Mathematical proficient students are also able to compare the effectiveness of two plausible arguments, distinguish correct logic or reasoning from which is flawed, and if there is a flaw in an argument, explain what it is. Elementary students can construct arguments using concrete references such as objects, drawings, diagrams, and actions. Such arguments can make sense and be correct even though they are not generalized or made formal until later grades. Later, students learn to determine domains to which an argument applies. Students at all grades can listen or read the arguments of others, decide whether they make sense, and use and ask useful questions to clarify or improve the arguments. This was the end of the standard mathematical practice of 3, construct viable arguments and critique the reasoning of others. Going on to 4, model with mathematics. Mathematical proficient students can apply the mathematics they know to solve problems arising in everyday life, society, and workplace. In early grades, they might be as simple as writing an addition sign equation to describe a situation. In middle grades, a student might apply proportional reasoning to plan a school event or analyze a problem in the community. By high school, a student might use geometry to solve a design problem, or use a function to describe how one quantity of interest depends on another. Mathematical proficient students who can apply what they know are comfortable making assumptions and approximations to simplify a complicated situation, realizing that they may need revisions later. They are able to identify important qualities in a practical situation, and map their relationship using such tools as diagrams, two-way tables, graphs, flowcharts, and formulas. They can analyze those relationships mathematically to draw conclusions. They routinely interpret their mathematical results in the context of the situation and reflect on whether the results make sense, possibly improving the model if it has not served its purpose. That is the end of 4 model with mathematics. Going on to 5. Using appropriate tools strategically. Mathematical proficient students consider the available tools when solving a mathematical problem. These tools might include a pencil, paper, concrete models, a ruler, a projector, a calculator, a spreadsheet, a computer algebra system, a statistical packet, or dynamic geometric software. Proficient students are sufficiently familiar with tools appropriate for the grade or course to make sound decisions about when each of these tools might be helpful. Recognize both the insights to be gained and their limitations. For example, mathematically proficient high school students analyze graphs of functions and solutions generated using a graphing calculator. They detect possible errors by strategically using estimations and their and other mathematical knowledge. When making mathematical models, they may know that technology can enable them to visualize the result of varying assumptions, explore consequences, and compare predictions with data. Mathematically proficient students at various grade levels are able to identify relevant external mathematical resources such as digital content located on a website and use them to pose or solve problems. They are able to use technology tools to explore and deepen their understanding of concepts. That is the end of 5. Use appropriate tools strategically. That was terrible pronunciation. 6. Attend to precision. Mathematically proficient students try to communicate precisely to others. They try to use clear definitions in discussions with others in their own reasoning. They state the meaning of the symbols they choose, including using the equal sign consistently and appropriately. They are careful about specific units of measure and labeling accesses to clarify the correspondence with quantities in a problem. They calculate accurately and efficiently, express numeral answers with a degree of precision appropriate for the problem context. In the elementary grade, students are carefully formulated explanations to each other. By the time they reach high school, they have learned to examine claims and make explicit use of definitions. 7. Look for and make use of structure. Also, that was the end of 6. Attend to precision. Starting 7. Look for and make use of structure. Mathematically proficient students look closely to discern a pattern or structure. Young students, for example, might notice that 3 and 7 more is the same amount as 7 and 3 more, or they may sort a collection of shapes accordingly to how many sides the shapes have. Later, students will see 7 times 8 equals the well-remembered 7 times 5 plus 7 times 3 in preparation for learning about the distributive property. In the expression x to the second power plus 9x plus 14, older students can see that 14 as 2 times 7 and the 9 as 2 plus 7. They recognize the significance of the existing line in a geometric figure and can use the strategy of drawing an auxiliary line for solving problems. They also can step back for an overview and shift perspectives. They can see complicated things such as some algebraic expressions as single objects or as being composed of several objects. For example, they can see 5 minus 3 start parentheses x minus y end parentheses squared as 5 minus a positive number times a square and use that to realize that its value cannot be more than 5 for any real number x and y. That is the end of 7. Look for and make use of structure. We are going to 8. Look for and express regularity and repeated reasoning. Mathematically proficient students notice if calculations are repeated and look for general methods and for shortcuts. Upper elementary students might notice when dividing 25 by 11, they are repeating the same calculation over and over again, and conclude that they have a repeating decimal. By paying attention to the calculation of slope as they repeatedly check whether points are on the line through 1, 2 with slope 3, middle school students might abstract the equations parentheses y minus 2 end parentheses in the numerator going south to the denominator passing the verticulum or fraction line into the denominator start parentheses x minus 1 end parentheses all equals 3. Notice the regularity in the way terms cancel when expanding. Start parentheses x minus 1 end parentheses start parentheses x plus 1 end parentheses comma start parentheses x minus 1 end parentheses start parentheses x to the power of 2 plus x plus 1 end of parentheses comma and start parentheses x minus 1 end of parentheses start parentheses x to the third power plus x to the second power plus x plus 1 end of parentheses might lead them to the general formula for the sum of a geometric series. As they work to solve a problem, mathematically proficient students maintain oversight of the process while attending to the details. They continually evaluate the reasonableness of their intermediate results. That was the end of 8. Look for and express regularity and repeated reasoning.